Welcome to midweek space startup news. So I'm just going to go over space news I found on social media or websites. So first of all, if you're not aware, we have a account on X at Space Startup Hub, so you can follow us on there, notifications about videos that have been published. So let's get into the first article this week, and it's on InnoSpace. So they attempted to launch from Brazil at Alcantara Space Center. So the article says South Korean startup InnoSpace fails on its first orbital launch attempt. The company launched its Hanbit Nano rocket from the Alcantara Space Center in Brazil on Monday at 8:13 p.m. Eastern Standard Time. It was the first ever launch attempt by a South Korean company. I need to qualify that statement. The first attempt by a space startup or a private commercial company. South Korea does have national rockets or government rockets that do launch, but this was definitely the first space startup that attempted to make an orbital launch. So it's 57 foot long, the rocket, or 70 meters, and it came crashing back to Earth about a minute after liftoff. InnoSpace did not immediately provide an update on X, and I've checked. I've not seen anything from the company on X so far. And the company cut off its website in the wake of the incident, shortly after announcing that an anomaly had occurred. Hanbit Nano is a two-stage rocket whose first stage burns liquid oxygen and paraffin. The rocket is designed to deliver up to 198 pounds, that's 90 kilos, of payload into a sun-synchronous orbit from Brazil. The company is also developing larger, more powerful rockets called Hanbit Micro and Hanbit Mini. So that's the article, and as it stated, the rocket failed. We actually do have some video because InnoSpace did live stream the launch. It was possible to follow it. Unfortunately, it's night, so you can't really see much once it goes above the clouds, but you can see the liftoff looks good, and then some kind of drone shot, and you can see it fly upwards, and then it goes above the clouds, so then it's difficult to see much. So I mean, it's working fine at this point. So a minute into flight, and then once it goes to max Q, and then there's an anomaly. So now it's just pitch black, but you will see a little flash any moment now as it passing max Q, and there's a frame or two where you can see an explosion. There you go. And that's all you can see from the video, but I have freeze framed the explosion, and here it is. So passing max Q, and there's some kind of explosion. Maybe it's a structural problem as it passes maximum aerodynamic pressure. Maybe something wasn't structurally sound. But we have no information from InnoSpace, so we don't really know what's happening. In terms of InnoSpace, they've been working on their orbital rocket for a while now, done lots of testing, vertically integrated. They've got their own launcher, carbon fiber first stage, paraffin and liquid oxygen they're using on the first stage, and the second stage could be paraffin, or it can actually be methane as well. So they've got a whole family of rockets they're working on. Hanbit Nano is the first one, and then they've got a micro and a mini. That's what we know about the problem. So this is clearly a setback for InnoSpace, but it's not surprising. It was the maiden flight of a brand new rocket from a space startup. So it's almost guaranteed to have some kind of problem or issue. So while it would have been ideal if it got into orbit, I'm sure they'll learn a lot. Hopefully they can troubleshoot all the issues and get to orbit. So in other news about InnoSpace, they have quite a few launch sites. So they launch from Brazil at Alcantara Space Center. They also have offices in Europe. They will be launching from Andøya Spaceport in Norway at some point. United Arab Emirates, I believe they have a launch site there. And they've just recently announced that they've got a launch site in Australia at Southern Launch. And here's the X post. So it says InnoSpace has signed launch site agreement with Southern Launch Australia. So beginning in 2026, InnoSpace will have long-term access to Southern Launch's Whalers Way Orbital Launch Complex and the Kaniba Suborbital Test Range for the next decade, expanding its capabilities across satellite launches, technology demonstrations, high-altitude flight tests, and space-manufactured product return missions. So that's referring to Vada Space. Their space capsules do return to the Kaniba Test Range. They've landed at least 2 of them there so far, and more to come. Low population, favorable trajectories for low Earth orbit and sun synchronous missions, and minimal air and sea traffic. So you're up to date on InnoSpace now, and hopefully we'll get some updates from them in the future. So let's move on to our second story this week. Okay, our second story is on the Exploration Company, which is a European company working on designing and building a cargo vehicle that can travel to commercial space stations and maybe in the International Space Station and deliver cargo. And in future, it could be evolved to carry crew. So we have an article from the European Spaceflight.com website. So let's just read that. It says the Exploration Company is developing an in-orbit servicing vehicle. This is a new vehicle. It's different from the cargo vehicle that we know about. It says the Exploration Company is developing a spacecraft designed to dock with and refuel as part of the European Space Agency's InSpace Proof of Concept or InSpock initiative. So they're developing a modular capsule called NIX. This is the vehicle we know about, the cargo vehicle, which will be capable of delivering cargo and later crew to and from destinations in low Earth orbit, lunar orbit, and the surface of the moon. So they have three variants of their NIX vehicle. They have what's called NIX Earth, which is for low Earth orbit. They have NIX Gateway that can go to the lunar orbit. And then they have NIX Moon, which is able to land on the moon. So continuing on with the article, it says, working on a spacecraft called Aura, designed to refuel satellites in orbit. ESA's InSpock initiative to develop a system capable of docking with client spacecraft and refueling non-cryogenic propellants. So this will enable spacecraft to move, operate, service, refuel, and interact with other vehicles in orbit. So they've been awarded a Phase B2 contract for the InSpock 1 program. This means they will be developing a prototype and a demonstration. It goes on to say the company will then start working towards an in-orbit demonstration, which is expected to be launched in 2028, which so happens to be the year that potentially they could travel to the International Space Station with a cargo mission. I believe that was also for 2028. So the demonstration will see the Aura dock with a client satellite, which will be built by Thales Alenia Space, in low Earth orbit and complete non-cryogenic propellant transfer. InSpock 1 initiative is also focused on developing standardized docking interfaces, and this lays groundwork for a sustainable in-orbit servicing and logistics ecosystem. That is the article from the European Spaceflight website. So we do actually have some information on the InSpock ESA initiative. I've covered it in Space News previously. So we look at this slide. So InSpock 1, this is proof of concept. So in space, proof of concept 1, and then there's an InSpock 2. So 1 is rendezvous and docking. So the idea is to equip spacecraft with tech to find, approach, and attach. This is kind of the RPOD, remote proximity operations and docking. This would allow transfer of payloads, satellites, propellant stations, and commercial space stations. And then there's an InSpock 2, which is later on. InSpock 2 is in-space cryogenic propellant storage. So InSpock 1 is non-cryogenic. So it's things like xenon gas, krypton gas, maybe nitrous oxide, ethane. Basically propellant that doesn't have to be kept very, very cold. For instance, methane or hydrogen. So InSpock 2 is suitable for space tugs, spacecraft, satellites. So this is for high performance propellants. So the examples would be liquid oxygen, liquid hydrogen, and I added liquid methane, although it's not specifically mentioned by ESA, but that is also a cryogenic propellant, which is quite common now. So basically it's propellants that are high performance and need to be stored at very, very cold temperatures. We actually do have a graphic from ESA. This is on a different initiative, but it gives you the idea. You've got propellant stations around Earth, you have them around the moon, you even have them around Mars. And basically by topping up, you can easily move between the different systems, the different places, the Earth, low Earth orbit, the moon, the Mars, and so on. So that's the idea, propellant stations. Moving on to some more news about the Exploration Company. We have an announcement between Redwire and the Exploration Company. Redwire has technology in all the commercial space stations, the International Space Station. They're just very prominent everywhere. And now they have an agreement with the Exploration Company. So let's read that article. And this is on Redwire's website. It says Redwire awarded contract to provide spacecraft docking systems for the Exploration Company's European Space Capsule, which is NIX. You can see it there. There's a NIX vehicle. So it goes on to say, they announced today they have entered an agreement for Redwire to provide 2 international docking system standard compliant docking systems for the Exploration Company's flagship spacecraft, NIX. So NIX is the cargo vehicle. So they don't say what the figure is, but it's an 8-figure deal. So it's at least 10 million. somewhere between 10 and 100 million, and it will be for the International Berthing and Docking Mechanism, or IBDM. So this system was developed in Belgium in collaboration with the international partners and the European Space Agency. It's compliant with IDSS, so it supports both berthing and autonomous docking operations. So berthing is where a robotic arm reaches out, attaches to the capsule, and brings it in. So for instance, the Cygnus vehicle from Northrop Grumman is berthed. Then you have other systems like SpaceX's Crew Dragon and Cargo Dragon, which can autonomously dock. So there's two different modes, and the docking adapter supports both. So Redwire is working on a IBDM system for the Lunar Gateway's international habitat. So it'll be the same docking system for Gateway and for the NIX vehicle. We have a quote here from the Exploration Company. They're saying, with NIX, our goal is to build the most affordable and sustainable vehicle for space cargo transit. Partnering with Redwire on the NIX docking system strengthens that mission. So that is the article. As I was saying, Redwire seems to be ubiquitous in commercial space stations. They also provide the ROSA rollout solar arrays, which are on the International Space Station. Axiom Station will be using them. Redwire provide pharmaceutical experiments on the International Space Station, on vast space. So they're very, very prominent in the commercial space sector, for in-space operations. So that was very interesting. So let's move on to the next story. There are two large, well-funded space startups in Europe. One of them we've just discussed, the Exploration Company with their NIX vehicle. And the second one is Isar Aerospace. Both of these companies have funding north of 400 million euros. So let's talk about Isar Aerospace next. They have an article, but first of all, they posted a video. So let's just watch the video and then we'll have a look at the article. So this is their very first launch. This is the Spectrum rocket. This was 9 months ago, and it didn't work. So it blew up after about 30 seconds. No problem. They're working on their second vehicle. And then you can see it there being shipped to Norway, and it's undergoing testing. I believe it's finished its testing now. So it could be flying as early as January of next year. Obviously, there's a learning curve for private space startups. There's a lot of things that can go wrong, tens of thousands of components. So they're learning how to fly a rocket, and their second attempt will be coming up soon. And as I said, they're very well funded, so I'm quite confident they will figure it out. Let's read the article. So this is on Isar Aerospace's website. It says, less than 9 months after first test flight, Isar Aerospace clears final tests for second Spectrum launch. And it goes on to say, less than 9 months after Spectrum's first test flight, Isar Aerospace has completed stage testing and is preparing for its second launch from the company's dedicated launch complex at Andøya Space in Norway. So Isar Aerospace's rapid pace is powered by its vertically integrated automated production system built to deliver launch capability at scale from European soil. Spectrum is designed and manufactured almost entirely in-house, and they can produce more than 30 vehicles per year in its new 40,000 square meter facility near Munich. As I said, they're well funded, so they've got a state-of-the-art manufacturing facility. They can produce a lot of vehicles. They just have to learn how to fly them. So this will be their second attempt. Talking about funding, we had this fairly recently. This was actually the 15th of December. They won 205 million euros as part of Europe's launcher competition. It's called ELC, the European Launch Competition. 5 space startups were selected. One of those was Isar Aerospace. So it says here, 205 million euros commitment to Isar Aerospace by the European Launch Challenge is a clear signal that sovereignty comes from competition and commercialization. Finally, Europe is waking up and starts changing its approach to launch. Their backlog is getting quite long now. This is a list of payloads, but I think it's out of date. The payloads go back all the way to 2021, but I think it's even longer now. You can see there that this is the launch pad in Norway, Andøya. InnoSpace is also potentially launching from here sometime in the future. At the moment, only Isar Aerospace is using this facility for orbital launches. And this is the first flight and another image of the launch pad. And we actually have a video of the first flight. This was 9 months ago. And this is their Spectrum rocket, 2-stage rocket. So you can see it lifts up, no problem. And the first 10 or 15 seconds, everything seems to go according to plan. But if you notice, it starts to wobble slightly. So there's a problem with GNC. It seems to wobble, and then it just pitches over completely. There it goes. And that's the end of the mission. It just drops back and explodes, which you don't see on the video. That was the first flight, but that's expected. The same as InnoSpace, the first flight, it failed. So that's all the news this week. Thank you for watching, and I'll be putting out another video later this week, probably on Friday. So please like and subscribe, and I'll see you next time.